Hey, good evening, guys. Okay, so this is assignment 2, question 2 about the weight study, about the microbiotic low fiber and high fiber in the 24 freshman women. So the first thing we have to do is we have to do a little bit of making sure our data is good. By looking at the, what do you want to call them, like the homogeneity of variance and those things that you do at the beginning. So you click on Analyze General Linear Model, Univariate, and you're going to put the rate of gain as your dependent variable, the research group as your fixed factor, and then your initial weight as your covariate. And then you're going to click on Model and Custom, and then you're going to move Group over, which is already over. Going to move Initial Weight over, and then you're going to highlight both of these, Group and Initial Weight, and move both of them over, and click Continue. And once you have that all done, I like to check the box of descriptives, the estimates, and homogeneity of variance. These I was playing around, so I'm going to move those back and click Continue, and then click OK. So here it's showing us your descriptive statistics, what rate of gain for each of the different areas. And then the Levine's test shows you that you have homogeneity of variance. And then your test of between subjects, this here is kind of like one of your Levine test things. You're actually doing the test of regression analysis. And so if you look at group asterisk initial weight, you notice that the sig value is 0.365. For this particular analysis, you want that sig value to be not significant. And so our regression is not significant, which means that it's met. So if you look here, I have here that the homogeneity of regression, which is we have 2,18. That's how we're getting this formula, and then it's equal to 1.07 if we round, and the p-value is 0.365, and so we say it's met. So both the Levine's test, which was up above, right here, we have our f-test here, 2,21, you're taking D1 and D2, and putting them in parentheses, is equal to 3.07, and the p-value is 0.068. So both of these assumptions are met, so that's good. So the rate of gain is normally distributed, and there's also a relationship between the dependent variables and the covariate. And I think that relationship is based on having the Levine's test and the homogeneity of regression met. Okay, so now that we know that our assumptions are good, now let's actually do the real analysis. Okay, I stole this regression table off of, or sorry, this descriptive table off of the initial analysis for these numbers here. But to do the real analysis, you're going to go back to Analyze, General Linear Model, Univariate. And all of these are going to stay as they are. But then instead of doing the custom model, you're going to do the full factorial model. This will give you your comparison table, so you know exactly how everything is significant. And because we've already selected all of these, we don't have to do anything there. And I'm pretty sure Bonferroni pops up, so let's check it out. We press OK. So now here's your descriptives. Here's your Levene's test for the actual analysis. And we've already talked about it, so I don't think you have to talk about it again. But now here's your test of between subjects. Now this particular table, we're just interested in the initial weight, the group, the error, and the corrected total. So notice here, my numbers are exactly the same. And I have the initial weight, group, error, and total. And then the eta squared, 0.665 and 0.623 are here. Now both of these are significant. That's good. So what table 3 is showing us is that the analysis of covariance table, we've summarized the one row for the group. So F2, 20 is equal to 16.15, and it's less than 0.001. So we can conclude that there are group differences on the rate of gain for the 3 different diet regimens. So when the initial weight is controlled for. So what does that really mean? So since there's significant differences, now we have to actually look at where there are differences. So we also want to note that the eta, which is the n squared, is equal to 0.623. So that's about 62% of the variance in rate of gain can be explained by the variation of the different regimens, the diet regimens. So whenever you see eta, basically, we're always going to use it in the same kind of format. We're always going to say about whatever that percent is about that percent of variance in whatever your dependent variable is can be explained by your independent variable. And that information is right here. So we say about 62% of the variance in rate of gain can be explained by the variation of the different diet regimens. Okay, so now earlier we performed one-way ANOVA without considering initial weight. Let's do that real quick. Mine, when I did this just a little bit ago, it didn't come out exactly the way that I had on here, so we'll see if this works out for us. So we go to options, click on descriptives and homogeneity. We move the rate of gain to the dependent and the research groups to the factor. And we can click on SNK or Bonferroni. Let's click on Bonferroni and Games Hall and click OK. So when we do that, then our ANOVA table looks like this. And notice that it is significant, saying that the analysis between the 3 groups is significant. And when you look at your postdoc, it appears that like everything is significant. Now we'll have to go back to the initial one where we did the covariate to see what that postdoc looks like. But this the reason that we're looking at this is that we wanted to show that when we performed the one-way analysis without considering initial weight, we found no group differences in the rate of gain. Now that's interesting because this clearly is saying that. I must be doing something. Well, I know what it is. That's interesting. Okay. Well, this part of the analysis you don't have to really talk about, I don't think. So let's go back up to our analysis with the covariate, okay? So here's the analysis with the covariate right here. So because there are group differences, we're going to look at our post hoc. And so when we look at our post hoc, now, of course, it doesn't want to show up. So let's try this again. When I did it earlier, it was working. So we're going to go to Analyze. I'm just going to redo it. So this will just be a reinforcing. Univariate. And we have the rate of gain in the dependent, fixed factors, the research groups, initial weight as a covariate. In order to get the post hoc multiple comparison, you have to click on full factor. And maybe it's because I didn't move these over with the groups and click on Ferroni. So let's go ahead and do that. And then I've clicked the descriptive statistics, estimates of effect size, and homogeneity test. And then click OK. So when we do that, our group differences are still saying that we have group differences. And here's just a summary of the grand means. And then here is the means once they were adjusted. Notice that these means are slightly different than the means that were up above. So here the microbiotic is 17, the low fiber 20, high fiber 23. When you look here at the adjusted means, they're just slightly different. Microbiotic is now 18, low fiber is still 20, and high fiber is 22. So, but here's our pairwise comparison table. Woohoo! Okay, so now with this, we can write about our actual analysis. So with the pairwise comparison table, this table here we're going to put into a table like this. So we write out our 3 different diet regimens, and I number them so that I can put across the top just the numbers 2 and 3. And then I put the new numbers for their means for the adjusted means, which is the one that was right above this. So here where it says estimates, notice underneath it, it says covariates appearing in the model are evaluated with the following values. So the initial weight was 109. So this information here has been adjusted. So we put those numbers into here. Notice that they're pretty close to the same values. I wonder why they're different. Let's look at the original values. Maybe it's a slightly different file, but anyway, in any case, so you have points that we're looking back at the pairwise. So we have 0.006. Because of this sig value between microbiotic and low fiber, we're going to put an asterisk. Okay? And that means that they're significantly different. And then because of this 000, microbiotic and high fiber also get an asterisk, meaning that they're different. And now when we look at low fiber and microbiotic, well, we just put an asterisk from up here there, so we don't have to do it again. So now low fiber and high fiber is also significant. So low fiber and high fiber is right there. And then the rest of these just repeat. So This 001 high fiber microbiotic was here at the beginning. So we don't have to do any repeating. So it'll always look like a triangle. So now it's time to talk about them. Typically we put underneath the table, we put what our asterisks mean. So I'm going to just say that P is less than 0.05 so that we know exactly what that means. And so now we can talk about our major findings. So our major findings is that the microbiotic group after the intervention has statistically lower weight gain than both the low fiber and the high fiber groups. Now notice I put in the means here to indicate to the reader what the means were for each of those groups. And then additionally, the high fiber diet has significantly higher rate of gain than the low fiber, and I put in the means. Therefore, if women would like to gain weight at the fastest rate, they should choose the high fiber diet rather than both the microbiotic and the low fiber. So that was my conclusion for this study. Now, this stuff in here, I don't think it's really necessary, but you can decide for yourselves if you want to put it in there. But overall, the Ancova table was this test of between subjects, initial weight, group, error, and corrected total. And then this pairwise is the pairwise comparison here. Okay. And I think that Kajai does it on purpose, that the numbers are just slightly different to make sure that you guys aren't copying different stuff. So I'm not going to worry that the means are just slightly different on this one. But I hope this has been helpful. You guys have a great night, and we'll talk to you later. Bye.